bringing up to the stage our keynote today, Dr. Marty Trevino. He's going to be talking about the future of AI and how it will impact healthcare. So Dr. Marty Trevino is a cognitive neuroscientist specializing in how human brain trusts and make decisions with data and next generation human AI complementarity. I practiced that one all day. Close, right? Today he is a contract executive and scientist working with governments, corporations, and universities. Dr. Trevino is a requested speaker and published author. Previously, Dr. Trevino was a senior NSA, National Security Agency technical officer. Join me in welcoming Dr. Trevino to the stage.
Okay, testing. Not working? I'll take yours. There you go.
There we go.
We know this one works. Okay. I realize that I'm standing between you and some good food and a couple of cold drinks, so Shrag has me listing this to 7 minutes. I will try and keep it there. Well, first off, these are really difficult because you sit down and think for a week or two prior to what you want to talk about, and then you listen to the absolute brilliant minds that go before you, and you've completely derailed my talk. Complete, from the awesome venture capitalists, right, serving the underserved populations, to brilliant thinkers and people doing things on every level that are just changing the world for the better. My specialty is human artificial intelligence complementarity from a neuroscience perspective. I believe we make a tremendous error in our organizations when we incorporate, when we go through our digital transformations or we're looking to fund new business models, and that error is that we tend to approach the integration of technology, in particular artificial intelligence, from a pure technical standpoint. And I've heard a lot of that today. We talked about the technology. We're incorporating algorithms and AI into the diagnosis and into every part of the continuum of providing awesome medical care. We can now read MRI scans that much faster, that much more accurate, et cetera, et cetera. Those are fantastic. But I didn't hear a single person talk about the human factor, or very little, right? And here's a good one. I have the privilege of participating with venture capitalists and C-suite officers, and they say, as part of our digital transformation, we really want to incorporate artificial intelligence, we want to incorporate advanced analytics and visuals, and for defined outcomes, and all good. Have you ever, at any point in that process, talked to a data scientist or a coder or a project lead at the very onset of development when they said, we have a brilliant idea and we're to do this? Have you ever heard any of them say, but we want to start with the human factor? How does the human brain make decisions? How does it make decisions with data? How does memory function? How does working memory function there? How do we interrogate data? How do we interrogate problems? How do we trust data? How do we trust technology? Has anybody been part of that decision in the very, very early stages? Because I never have. It's always at the back end when we begin with the math, the method, the data. We need labeled data. We need a cloud-based, and the algorithms will do this and that, and then the precision and accuracy. And at some point, way at the end of the process, someone says, oh, by the way, how do we get people to trust data? Well, you're a little late. So I approach human artificial intelligence complementarity from that lens. And this brings us to the wonderful point that some of our venture capitalists and investors have made today, that for the last 50 years, the overwhelming majority of advancements in just about every aspect of society have been through technology. And that's true. We don't live in the world of the Jetsons, if you remember that old, right? Human society today is in many ways very simple, very back to the 1960s. But the advancements we have made have all been through technology. And many of our rate of returns, I mean, everybody wants to pay the rent. Some of us even want a little bit more than that. And for people investing, right, they have to gauge those investments on what's going to yield the best rate of returns. And we live in a power law of returns that every venture capitalist and investor will tell you. There's a power law that exists out there, and that's important to understand as we invest in the future, whether it's through digital transformation or new companies, that the top 2 companies that you invest in, the 2 that get it the most successful, will be worth what the entire bottom half of the portfolio is worth. That power law is important because we have to get it right. Now, that brings us to a really good aspect. Most of those technological improvements over the last 50 years have been predicated on a very simple, elegant presupposition or tenet. Someone, intuitive and smart, said, what if we do this? What if we do it differently? And when you look at the major technological advancements and you go back and say, how the heck did you come up with that? And it's always a simple story. They said, well, I was just sitting there looking at a problem, and it's been in front of me for days or weeks or years, and I wrote it down on a cocktail napkin and just said, what if we did this? Most technological advancements can go back to a very simple scientific theory or premise. So as we stand going forward into the next several years, and this is a question for everybody in this room, because we have investors here, we have providers, we have technologists in the room. Is there a simple, elegant primer that we can apply as a center of gravity to all future business models, regardless of size, that will function as the basis for innovation and problem solving, and help vault us to the top of that power curve of rate of return so we can do other things? I believe the answer is yes. I believe it's yes. And it's a very simple, very elegant premise that I tell everybody that I can. The key to success in the next 40 years, to defined outcomes, beautiful pathings through healthcare, and wonderful rate of returns that we can go on and do many, many other good things, is very simply this: human artificial intelligence technology models of complementarity or augmentation. Now, we will see replacement of people in the workforce. It will happen. But the conversations in healthcare are actually quite good. I mean, wonderfully good. We rarely hear that the wholesale replacement of people in organizations. No one's talking about firing half the organization. And the outcomes of pairing people, highly skilled, highly trained, very dedicated people, to forms of artificial intelligence or algorithms produces the best outcomes. And I don't think anybody rational would say we're going to terminate every person in this area and replace them with some form of AI, much less generative AI, and can come up with better results than if we mated highly skilled, intelligent people with the AI. The devil is in the details. We need novel forms of human artificial intelligence pairing to solve what are today impossible problems and innovate. And that goes back to what our awesome venture capitalists are looking for. Something that is defendable, not easily replicable, that scales at speed and scale, right? No one's looking for incremental returns, even though they're fine. A 10% increase in productivity is great. More accuracy, more precision, phenomenal. Do it. But if you're looking for order of magnitude, returns and improvements on every aspect of patient care, we're going to have to do it through novel forms of mating humans and artificial intelligence and technology together. And that's what we should all as leaders be looking to do. Now, what is AI? This is a really good question, and we're gonna tap this hard, because nothing is sexier than AI when you say the words. You say the word AI, and everybody says, "Ooh, orange." Say it again, slower. Yum. We do not have artificial intelligence today. Okay, not in the way that the only general purpose intelligence organism functions, the human brain. Okay. Artificial intelligence today is not intelligent. It is certainly not sentient. I don't care what a terminated Google engineer says. It does not possess intelligence. It does not possess knowledge. It does not possess awareness. It does not solve problems in the way that the human brain does. It does not function as the neocortex does. It does not create memory the way the neocortex does. But we call it AI. Well, that gets clicks, it's very sexy, it rolls off the tongue. What we really have, and this is important because the human brain uses reference frames as a basis for heuristics and decision making, and it's kept us alive for millions of years. So having the proper reference frame as leaders here is important. We do not have true artificial intelligence in the way that the human brain operates, or in the way that Hollywood has shaped us to be. This is not the HAL 9000. What we have are advanced systems of synthesizing, processing, and production. They're correlations, groups of algorithms using massive data with various learning techniques, whether they are through label data or there are many models of how artificial neural nets function. They do not work like the human brain does. But here's the kicker, and this is the most important takeaway from the next few minutes here. Artificial intelligence, as we know it today, we're just going to stick with the term. Artificial intelligence today is intrinsically different than the human brain, but uniquely complementary. It is intrinsically different, but uniquely complementary. And never in human history have we been presented with such a technology and an opportunity to do good and do things. Not in the agrarian revolution, not in the industrial revolution, and not in the information age, which, by the way, is ending. We are living it right now. The information age is coming to an end, and we are entering the age of augmentation. Right? Having information is wonderful. Computers threw it at us, they threw data models at us, tons of data, la la la. Today we're entering the age of augmentation. I can go home right now and pop up my phone and hit Bard or ChatGPT, and I don't have a lot of information. What I have is a system of augmentation. And that augmentation can help me interrogate data, explore data, look for ideas, create things. We're living in an awesome time, but the information age is now over, and we now live in a whole different age. And this age will be defined by cyber-physical integration, cyber-physical augmentation. How we do that from an ethics perspective, from a tactical perspective, how we integrate this in our digital transformations, what companies we fund, will determine so much of our future. And we have to get it right. And I'm not an expert in ethics, so I tend not to comment on things like that, regulation of AI, etc. I look at it from, here's how the human brain works, here's the technology we want to bring in. Now, how do we do this in a way that creates resonance, that creates trust in data? Because the human brain trusts data and technology in fundamentally different ways than it extends trust to other people. We now have numerous studies showing that. So if you say, well, we're just building this technology, we're going to throw it out there and let our wonderful, smart people in the organization use that. Well, if you acknowledge that human beings are half the equation, why did we leave human beings to the last 5% of it and then just shove it at them? That's what we did in the information age. Self-service BI, anybody heard of self-service BI, right? You know, you get they import data and they give you Microsoft has packages and ClickSense and Tableau. You can create your own dashboards and everything and put them up and you can now make data-driven decisions. Except the brain doesn't make decisions with data. There are separations between the limbic system and the neocortex, and how they function in relation to decision making is very distinct and intractable. The people who created business intelligence systems didn't stop to think of how the human brain actually interacts with data, how it actually makes decisions. We have that opportunity now in all of these new models of human AI complementarity. Now, one of the major pivots to what I was going to talk about today, we've heard a lot of fantastic examples, fantastic. But overwhelmingly, they were tactical. And this is good. I'm not diminishing it, right? Again, improving the accuracy and precision and determinations from an MRI scan is very important. And it yields wonderful benefits. But are there strategic, nonlinear, perhaps contrarian questions that we could be asking? There are systemic issues with the entire model of providing healthcare. I unfortunately lost a family member just about 2 months ago. And I got to watch the family navigate the system from injury, entry into a hospital, to about 6 weeks later, final days with in-home health. And I got a number of phone calls that said, what does this doctor mean when they say this? Please help us understand this. Where do we go? What do we do? And what struck me at the highest levels was the opaqueness of the system. The system is utterly opaque. And unless you work in this, even if you work in the system, it's opaque. But imagine now being someone who has not dealt much with the system, and you have to go into it, and it begins with taking a loved one into the ER, and immediately the administrators run up to you with a pile of paperwork and slap it down and say, sign all of this. Watching this journey of opaqueness was absolutely horrible. And it dawned on me that maybe there is strategic opportunity as we do all the tactical things to maybe start asking bigger questions. And I do a lot of work with cyber risk companies, in enterprise risk in Silicon Valley. And that's a common question that I have is, what are the bigger questions? What are the systemic foundational issues in the entire system, and can we address this? I think it's a wonderful topic today, right? Because we're talking about very tactical, wonderful things, but can we create a novel model of humans and artificial intelligence working together to correct some of the foundational parts of the system? And Greg mentioned me earlier, but that's in a sense, he's poking at that pretty hard, right? Functioning outside of the system with humans and artificial intelligence to guide patient and provider to optimal outcomes, to identify pathing. That's a good one. What if we could create a design AI that could show visually and informationally the pathing through the system that would validate decisions, provide information, provide understanding to both sides, and even relate to the physicians. And this is the concerns that the family has through natural language processing and through sentiment analysis and other things. What if we can inform all sides while we're doing the tactical? Could we alter friction in the entire system, optimize it so that perhaps the hospital organization isn't having to provide so much of this? True patient advocacy, true elimination of foundational issues and structures. I'm going to give you two real quick examples that are outside of the medical industry so that it inspires thinking, right? So much we think in our own realms. A few months ago, NASA engineers, widely publicized, you can look it up. NASA engineers are working on their new rocket going to the moon. We're going back to the moon. And they were having repeated failures with one part, and I'm not a rocket scientist, unfortunately, but one valve kept failing. And they had redesigned this valve a dozen times. And, some of those brilliant engineers on the planet. And one of them had the brilliant idea to create a design AI, feed all the parameters in, feed all the failures in, pressures, etc., size, weight, composites that could be used. Took about 3 days to feed all the parameters in and then hit go. It took the AI 1 day to come up with an absolutely novel valve structure and metal composite. They then shot that over to the 3D printer, which happened to be in the next room. And in a couple days, they had the new part printed up, and they marveled at the design, which in their words, they said, we just never would have thought of this. We've been designing valves for 20 years, and we never would have thought of this. They then sent it over and started the engineering stress tests, and last I heard, it had passed all of its stress tests. That is what I'm talking about. Novel models of human artificial intelligence integration. Second quick example, same on the whole NASA front. A couple of years ago, NASA created a AI program for the new telescope the James Webb telescope that had gone up, and they wanted to find new planets scanning the solar system. And so the data scientists came up with a new program, and one of the NASA engineers, widely published, said, well, maybe we should put this data out, what we're finding, we're not finding, blank spaces, out to just novice astronomers, people with big telescopes in their backyard that spend their evenings, instead of drinking wine and enjoying a good article, they spend their time watching the stars. And of course, the designer of the AI said, absolutely not. This AI will find everything out there. No human being can compete with it. It can compute 50 billion computations per second, and there is simply no point in involving ignorant, less capable human beings in this process. So they said, okay, you know best, we guess. 9 months later, they had discovered 300 new planets. Not bad. Except another astronomer said, based on the density, based on the rate of discovery and other factors, we know we're missing a lot. And the math doesn't lie. So even the head designer of the AI said, yeah, you're right, we're missing something, and I have no idea because I've designed the ultimate program, and it's the ultimate AI. Right? Yeah. So they reconfigured it to provide the information and insights from the artificial intelligence program to anyone who wanted to go and download it, with very specifics. Here's where we found things, how we found them, all the characteristics. So again, humans and artificial intelligence working together. I know the result. In 90 days, little old people working with the AI all over the planet in a distributed way had found more planets than the AI had found. Never underestimate the human brain. But the two together have found over 600 new planets. And that's the moral of the story. Humans and AI are categorically different and uniquely complementary. And the key for future business models for the next 40 years is figuring out how to pair the beautiful human brain, the human-centric, and novel forms of AI that are being developed every day and increasing in capability every day, pairing them together in novel ways to solve problems and to innovate. It's not about replacement, it's about complementarity. And if you want a really deep discussion on the functioning of memory in the neocortex and how the invariant nature relates to the different way that artificial neural nets create records and how to pull those together, I'm happy to do that to you, but you gotta buy me a glass of wine, because it's gonna be a long, drawn-out discussion. We can go as deep as you like. Thank you so much for the opportunity. It's really great.
Any other questions? I'm actually curious, what are you working on right now?
Well, I've been publishing a few more high-level articles because of that. One of the really cool things that I was asked not too long ago was time is a bear for the brain, right? So human memory is very specific. It is time sequenced. It is invariant. And how can we take visual events, sequence them in time to tap human memory in such a way that the AI and the memory are complementary, and basically what I mean by so when we remember things, they are time sequenced, and you know this because we all have patterns. You wake up in the morning, you brush your teeth, you do your things, or when someone says, "Remember when this happened? Remember when we were at Disney World last year and we had that terrible soup?" Oh my gosh, yeah. And before that, and after that, we remember things sequentially. Okay, they are time sequenced. And the brain also remembers correlations, causality, and outcomes. The human brain is not intended to remember very, very precise things. Right? So when you meet people with exceptional memories, the proverbial photographic memory, which is not really such a thing, but people's memories function differently. They remember all kinds of specific things. Most of us remember correlations and outcomes of events, time sequence, so that we can avoid them or repeat them. Really good things, we want to repeat them. Really bad things, we want to avoid them. Okay? Functions very well. Computer memory functions fundamentally very differently. And even though they're trying to create an invariant nature to computer memory, it's not been successful at all. And by that I mean, one, memory points back at itself, but two, if I give you a part of a memory, it will recall the whole thing. Right? So again, I can say, oh, remember that LA trip and that horrible Indian food we had? Oh my gosh, yes. And then the memory will spew out. Well, that invariant nature is highly complementary to how computer memory is. And so think of a doctor looking at a patient's history, long history, and can we design the AI to bring up specific, highly relative things correlated to others, that it triggers the invariant nature time sequence in the brain, and then the doctor can, through natural language querying, say, okay, show me this. And it now spreads out and shows the entire sequence of events with all the gory details. Or, as we're exploring with one Silicon Valley company, can we do it? Can we do it in scaffolding? And this is fascinating, right? So again, in the medical profession, scaffolding is used, all right? right? To look at anything from virus structure to many other things. Can we take the same techniques with scaffolding, how one thing builds on the other, strength of relationships, and with a touch of a button, spread them out over time, or in density, or showing causality and correlation, so that the beautiful human brain says, I'm putting on my doctor hat here, says, aha, oh my goodness, that's right. And in doing so, eliminate a lot of the opaqueness and just empower the two things to do wonderful things together versus the technology does this and the human being does this. Order of magnitude improvements in everything we do through unique relationships. I've gone way beyond 7 minutes, man.
I have one question. Last one, Dr. Marty, on Neuralink, because you talk about the human brain and AI. Neuralink is touching those areas. I mean, you could do it off camera. I don't know.
Well, I was going to call Elon later tonight, except I don't know him. It holds infinite potential, right? Because, and I'll say not even just specific Neuralink, right? But implants. It is far more complicated, okay, than is generally let on in the media. So does and I'm not an expert in Neuralink because I tend to just avoid personally that conversation when people say, are we going to be in 10 years walking around like cyborgs and I'm going to have brain stop, just stop. But it is inevitable, right? And it's already begun with implants to correct hearing. But can we increase cognitive ability? Can we do a lot of things? It is inordinately complex. There are problems to be overcome. I mean, partially are just ignorance. We know a lot. Let me take high order functions. Limited to high order functions in the neocortex. We know tremendous amounts, but I will spend my entire lifetime, and I say die ignorant. There's so much we don't understand. There's high hope, and again, the technology is advancing, and I'm dying to see what the outcomes of the tests are. Not my area of expertise. I don't deal with that. I work with very senior executives and development teams to say here's how we want to integrate artificial intelligence and human beings in new relationships for defined outcomes. And it begins with some of the beautiful C-suite people we have here, and it goes down to, because current design teams today, there are just not many teams that have a neuroscientist on staff, right? So when they say we want to create higher degrees of resonance, right, in the brain with our visual analytics, okay, well, to what defined end? How do you do that? There are very specific techniques, so it's the most fun. But I don't venture into labs like that. I'm half doctor and half technologist.
Cool. We got one ready.
Hello. I really love that you have the human factor in the AI conversation. I was curious to get your feedback regarding about some sort of entity that essentially needs to monitor the fine line between what is good AI and what is not good AI. Is there some sort of organization to decide, okay, is Neuralink really maintaining the integrity so that we can maintain our human awareness and consciousness? What does that line be drawn, and who regulates that?
Are you familiar with the term "a wicked problem"? by definition, right? Yeah. By definition, a wicked problem, right? I don't have a good answer to that because you can trace that back to hate speech laws. Who determines whether it's hate speech? Who determines whether it's good or bad? I think this is a wicked problem for our generation because I don't think there's bad AI. I think there are bad people who use AI. And we see that already from people creating malice software to people deliberately putting out misinformation on things there's been a lot of talk around TikTok that they wouldn't hire people like me in the dozens and said, how do we make this addictive, right? And sure enough, if you've got your phone and TikTok clicks or Tinder clicks or Facebook clicks, you run over there for that release of neurotransmitters. Feels good. We have a real challenge with our society today. I'm a strong advocate of free speech and development and things, and the tech community certainly wants the government to stay hands off. But we're going to have some degrees of oversight and some ethics regulations that we will do no harm. But again, it's a big world. I served our country for many years in a technical capacity, helping military leaders make well data-informed decisions. And when you look at the world, not everybody means well. There are evil people in the world. So I don't know how we come to grips with that. And I'm not an ethics expert, so I don't dive too much into that. But it is a problem that mankind will have to come to grips with. And I don't think the current systems of government, the government today can't come to grips with cyber. And I'll tell you a quick 10-second story. When I was serving our country as a senior technical expert in mission analytics, had a congressman that summoned a team of people from the agency. And I was one of those people that went, and a congressperson, which will go nameless because that person is still serving today, said, "Doctor, when are you going to secure the internet? When are we going to stop all hate speech and all the and bad things and misinformation on the internet?" And I said, I don't understand the question. And this person said, "Well, let me speak slower for you then." Okay. When are you going to secure the internet? And I said, well, congressperson, we can't. And then the congressperson said, well, maybe if I fired you and hired someone more competent, we would be able to. That misperception is out there. And this is a highly intelligent, wonderful person in their domain who just did not understand the nature of something outside of their core competency. I truly don't have an answer for it, but I can absolutely see people doing badness with what we're creating. Even the generative AI, right, built on large language models, it's wonderful, but it has serious limitations. But even that, they're going to do terrible things with. Well, in some regards, that's nothing compared to what's coming down the pike. Nothing. What we're going to see released in the next 5 years in terms of AI, or advanced information processing, synthesizing, and production systems, I just can't. If anybody has an acronym that would roll off the tongue really well, get with me. I'll buy you dinner. It's one of the questions of our time, because if we don't come to grips with it, many bad things will happen. Ma'am, do you have a question?
I do, yeah. And so I guess that's kind of to his point as well about this using nanotechnology and essentially going more towards that transhumanism aspect of things, which could be vitally dangerous. I guess in your capacity, I see a large differentiation between, like you said, it's complementary, the humans and the AI working together. And now from a neurocognitive standpoint, how do you see this working in its full capabilities and potential? Is it utilizing neuroscience and, so when you were speaking about the people and the planets and how they put out the data and the parameters to work with. Now, are these people that are working with that data, is there cognitive reflection into the AI that they're also a part of? Or is it just the mass of the human populace working within those parameters? Does that make sense?
I think so. We'll have a cup of coffee after this. So both. There are the openly accessed AIs that you find out there, and like now, so generative AI. You can go out there and you can do many wonderful things with it. But what I really say, in digital transformation and investing in new companies that come up and say, I have this brilliant idea, most of those cases are going to be very specifically designed AIs for their domain and to derive definitive intended outcomes. And those users are going to be a very specific, trained set of users, hopefully with a strong degree of ethics, depending on the organization. But again, we are different from China, for example, the ethic question. And then within those specific domains, over time, we will see things like Neuralink and other implants and other tactile, type devices. Okay, and even to go the other way. So we have several senses, but we know, okay, that if the human brain is fed another sensation, another source of data, if you will, there have been wonderful tests done for the blind, right? Who was it? Sorry, I can't remember the doctor's name. But they placed a device on the tongue, okay, and it provided sensation to the tongue to the blind as to where they were walking. The human brain picks up that new data source and begins to decipher it immediately. Within 90 days, those people, this device sensing the environment and providing sensation to the fully blind, were able to navigate complex obstacle courses. Right? The brain is not solidified. It is very agile. It can do wonderful things. The case of London cab drivers having to memorize every street, the hippocampus grew by 30%. So it's not just even implants. It's can we provide new data sources through devices that the human brain in all its beauty will interpret and be able to do even more wonderful things. Those experiments are going on, by the way, right now with stockbrokers. They have electrotactile devices on their arms and on their chest, and they're being fed direct data streams on stock market data. Can they feel the data? Can you make better trades, better insights? And to see, some of the readouts of those is phenomenal. That a stockbroker, stock analyst is literally sitting there looking at data, and the data stream changes, and they can feel that. The brain picks it up and attempts to sense make of it, and they say something's wrong. There's an opportunity somewhere. Where is it? We don't know. Let's find out. And they move in a direction to try and find that new stock. Okay? What if we could translate to the medical profession? That based on all the data from 17 wearables, each one of them picking up 15 different metrics measures, that could be fed into your own personal archangel AI that knows you. The unit of measure is 1. It doesn't know the whole population. You have your own, you have your own, I have my own. And somehow it can relate to the doctor when the doctor is sitting there, or even again virtually telemedicine at speed and at scale. Someone, somewhere, something, whether it's the AI or a human being, says something's wrong. And we know we can do this, right? We can predict all kinds of catastrophic events now, hours and days ahead of time. It holds infinite potential, infinite, and we have to be asking bigger questions. It's not just about, can I read, a CAT scan faster or more precise or more accurate? Bigger questions. And maybe we can change the system at its systemic and foundational levels to do all kinds of wonderful things like prevent bad outcomes, but also serve underserved populations in ways that today are not possible. And now I've kept you from dinner too long. Thank you so much. It's been my honor.
Thank you, Dr.